You're welcome. Good morning, everyone. My name is Amy DeVet. I am a student at Automation Works, and this is my first term project. And my problem identification and motivation came from looking at a candy dispenser which dispenses candy. And I was just wondering, because bolts are the same size, basically the same size as candy, so why not have a machine that can do the same thing but just with bolts? And also because I'm here and now I see for myself how bolts can get easily lost because of the small size. My problem statement is to build and design a low-cost mechanical operated bolt sorter to grade bolts to the same size in workshops to save time and increase productivity. My solution process was to do a lot of research about how other people went and had their own method of having a solution to my problem. And I had to take a lot of consideration into what I will be using and what I want to take out from my design. How my project would be helpful in the real world. It would help businesses and workshops to keep stock of their bolts and inventory control so that bolts don't just get lost and then there's not enough in the specific category that it was supposed to be. Section B. Just a quick rundown before I continue, because with the others' explanations, I have to explain this. So those who are sitting at the back, if you don't mind coming forward, just come and see if you're not able to see from the back. Okay. So as you guys can all see, these are the slides at the front, and they're all spaced out. And right here, you can all see that there are like steps, but these are the lifts that lift the bolts up. And this is the hopper. And the gray part right at the bottom is the gearbox, which two big gears and one small gear are all situated in that one space. And the small gear is controlled by the handle, which is a threaded rod at the back. And you can all just go and sit again so that I can continue. So the gears help to move the lifts, which will, like I said, get the bolts to the right categories. And by using the handle, it would help move the gears so that it could make that movement for the bolts. And my innovation, what do I see as unique in my solution? Well, I found this company who created a bolt sorter, but theirs is much more larger, which is yay high, theirs, and way more expensive. That their expense for their bolt sorter is $2,000. And it's not accessible for all countries. It's only accessible for just some. And theirs can do more than just sort bolts, but in my one, as you can see, it's much more smaller, and mine only goes from M3 to M5. And mine is not as expensive as theirs because mine is much more smaller in size. Section C. This is my hand sketch of my design. This is my CAD sketch for the whole process. And this is the 3D model where you can clearly see the gears, which is controlling my steps. And I had a lot of different ideas for how the bolts would be sorted. So in this case, by my first photo, you can all see this box-like figure, which would have been controlled by a piston, but then I had the problem where the bolts would have no control at the end and just hop around, and the wrong bolt would go into the wrong category. And in this one, it's the same idea, but just it was more like it would have had this contraption, but it would have had the same problem. There would be no control. So I'll just send this around that you can all see it. And by the product testing, I had to do a lot of test runs before I came to the end result. And I brought a few of them of my little test where the lip was too high up, so the bolts would get stuck. By the second one, I got the lip a little bit lower, but the problem was I had the same size again. So I'll be sending these around as well so that you can see the differences. But Section D. The tools I used to create my project. I used 3D printing. I used a hand saw for cutting the threaded rod. I used a laser cutter for the acrylic boards that you guys can all see, the one over there and the one just at the bottom of the hopper, and the screwdriver to put the screws in so that it can be all hold together, and a file for the threaded rod so that it can fit into the small gear. And the skills I used was, the skills I learned throughout this term was how to use Fusion and how to use a laser cutter and time management. With laser cutting, I had to learn about what safety protocols I have to use before using it. And with Fusion, I had to get used to using it, so I played around with it a lot. And I made this little fella to get used to 3D printing, but I also learned my lesson that 3D printing takes up a lot of time in this case. So that's why I had to do time management and learn how to work with it. And in this case, assembly sequence, there are 6 steps in mine. I had to do research about the bolt sorting and the design on Fusion, select materials to be used, testing, and assembly. As you can see, I was busy assembling this contraption, and the final testing. Section E. This is now a photo at the bottom about the Appendix bolt sorter, and I use them as my basic guidelines and research material the majority of the time for the bolt sorting research. And their website was updated last in 2020, so it's quite recent. And the research I went through and decided on the specifics was that a cheese head would be much better than using a hex head, because in this case, if the hex head would get stuck easily in my device, unfortunately, because of the weird shaped head. This is my activity log, and this is the amount of time I spent working on different things this term. So this is the amount of time I worked on my project, my theory, my tutorial project, my PPD in the morning with JC, my practical, and my personal experience. The most impactful PPD was identifying fallacies in my everyday life. For example, a slippery slope. Assuming one small step will inevitably lead to an extreme, unlikely consequence. So, for example, if your teacher tells you if you don't do your homework, you would never go to a good college and you would be a bum at home. My technical difficulties. In this case, previously I went and mentioned that I had to do a lot of reprinting, and the elevator not working. So basically in by my steps, unfortunately because of load shedding, my previous steps came out looking a little bit funky because of load shedding. But in this one, you can clearly see that there was a slant, and because of that, when I redesigned my steps, I forgot to put it in, so it's a little bit not slanted. So I have to slant the whole entire thing so that the bolts can go through. But you guys can see for yourselves later on how that worked, and the impact of the difficulty caused a slight delay in the finishing of the project. But my solution was to just design my project a little bit more simplex, because at first it was a little bit more difficult because I've added a lot of unnecessary features. And in this one, I took out the unnecessary features and made it much more simple. And my technical success. So I had a problem with the long bolts that couldn't get through to the other slides, so I had to come to the conclusion where I have to space out the different slides so that the long bolts can finally come through, and it was a technical success for me. And my future improvements. The bolts, I want to have the bolts to be able to be counted when falling through the slide, and I want it to be electrical, and I want my elevator, my steps, at least to be slanted so that I don't have to physically tilt the thing the whole time. And I wanted to have a solid handle because at the back, I forgot to mention, sorry, but I came to a little bit of a rough tough because there was too much space, so it's a little bit wobbly. But hopefully in the future, I don't have to put paper in there so that I have to hold up the threaded rod so that it doesn't completely go out the gear. And this is my bill of materials, and this is how much time I had to wait for the 3D printer to finish printing altogether, and this is how much everything cost me at the end, 214 Rand and 54 cents. And now for the demonstration. So just you guys can come closer from the back so that you all can see. Sorry. Yeah. So in this case, and just over here. Sorry. So it would basically look like this. Sorry. Huh? Yeah, the small gear at the front. There we go. So that would happen. So that's how it works. Takes a little bit of a time, but yeah, it gets there. Sorry. And I just want to say thank you for Nick for helping me to print all my parts, because it was quite a few. JC for helping with presentation practice, and Aunt Elmer for always pushing us to our limits, and Odie for always supporting me, and Kevin for always being willing to help me when I asked him for help. Any questions? And thank you. Yes?
I've got a question, a comment. So maybe for future improvements, that would be a big improvement if you can get it to sort the exports as well.
Yeah.
Because I think in a real world application, you'll have to accommodate that. And then maybe also, that's far down the road, what would be nice in a fully functional model, if the person that needs the bolt can press a button on a PLC, I need size 6 X, for instance, and that drops. So it's just something for real world application.
Yeah, I would keep that in
Really
mind.
good.
Thank you.
And also, your inspiration in the beginning, did you see in the workshop people struggling with the bolts and then see a chewing gum machine or whatever?
No.
Which one came first, and to make that connection between the two?
It actually came from me physically going down there and losing a few bolts myself, and then I looked at a candy machine and just thought, okay, that's actually a good idea if I just do that instead.
I mean, do you have any idea what makes the commercial product so expensive? The one that you said $2,000. Why isn't there something cheaper? It seems hard to do, but relatively.
I would say because theirs is a little bit more expensive because it does more than just sort. It also creates bolts in that sense. So that's also why it's a little bit more costly. Any other questions? Thank you. Thank you for your time.